Hello everyone, welcome to today's session on electricity. And today we will look at the resistors in series and parallel combinations. Okay, so first let's look at the resistors in series. So when I was talking about ammeter and voltmeter, I did mention that ammeter always connects in series and voltmeter always connects in parallel. Let's see what is the series and parallel connections are. Let's say I have one resistance here, and then I have another resistance. Let's say this is R1, this is R2. Both are connected one after the other. Understood? Both are connected one after the other. And this combination, let's say, is connected to a battery, to the positive and negative terminal. And then I have a switch, and then I have an ammeter. So the current I flows through this. And here in series connection, same amount of current flows through each resistance when they are connected in series. You understood? And the potential difference will be separate. Let's say this is V1 here, and here it is across the other resistor. This is V2. And this is the positive and negative terminal, and say this is V. So this is a circuit which is connected in series. So one after the other. The examples are, if we are in a, if you follow any event or a function, right? For example, marriages, you have a serial lights. That means if one light is lit, all the lights start lighting. If one light goes down, the entire lap will not have the electricity. That means it is like sequential. The current will flow in the first bulb, then it will go to the next like that. Understood? So that is a series connection, one after the other. Now, let's see what is the effective resistance when it is in series. So here in this circuit, in series connection, I is constant, right? The current I is constant. The same amount of current will flow through all the resistors. All right. Then what is V? V is the potential difference at the source should be equal to V1 plus V2. The potential difference across the resistor 1 plus the potential difference across the resistor 2. Then what is V? V equal to capital I into the effective equivalent resistance. I will say REQ. That is equivalent resistance. In the entire circuit, what is the equivalent resistor? I don't know. So I am taking this as capital I is the current, right? Let's indicate as capital I. And then R equivalent is the effective resistance or the equivalent resistance. Now, what is V1? V1 is same current, that is I into R1, the resistance of that first resistor. Then what is V2? V2 is I into R2. Now, if I substitute in this, what is V? V is V1 plus V2. What is V? V is I into R equivalent equal to I into R1 plus I into R2. So I into R equivalent can I write as, if I take I as common, I can write as R1 plus R2. Then what is R equivalent? I gets cut, right? Same side. So R equivalent is R1 plus R2. So this is the formula when the resistors are connected in series. If three resistors are connected, then R equivalent equal to R1 plus R2 plus R3 plus so on up to Rn. If there are n resistors that are connected in series, you just need to add all of them to get the equivalent resistance in the circuit. Understood? So R equivalent is R1 plus R2 or whatever, how many resistors that circuit has, all the resistors you need to just add them. That is the equivalent resistance when it is connected in series. Understood? Now, let's do a problem, right? So, in this example, an electric lamp whose resistance is 20 ohms. So, this lamp here is having 20 ohms resistance and a conductor of 4 ohm resistance are connected. So, a 4 ohm resistance is connected in series to a bulb. The bulb has a resistance of 20 ohms. That means these two are connected in series. Okay. Now connected to a 6-volt battery as per the figure here. Calculate the total resistance in the circuit. So the first bit, that is total resistance in the circuit, that is R equivalent, right? Total resistance is these 4 ohms plus the bulb is 20 ohm. Can I say this is 24 ohm because this is connected in series, right? The same amount of current is flowing through the circuit. So the current is not dividing. So this is in series. Let's say, guys, here I current is flowing, right? Here also I will come. After it passes, here also it is I. So to the bulb also, I current is going. So that means when the current is the same across two resistors, then those two resistors are connected in series. Okay. Now, so the total resistance is the sum of those two resistors, that is 4 ohms plus 20 ohms, which is 24 ohms. Now, what is the other one? That is A. It's not one, it is A. Now it is B. The current through the circuit. What is the current through the circuit? So what is the voltage here? Voltage at the source, that is 6 volts. And I, we need to find. What is R? The effective resistance in the circuit is 24 ohms. Now, according to Ohm's law, what is V? V equal to I into R. Right here, R equivalent. Now, what is I? I equal to V by R equivalent. What is V? V is 6 by 24. 6 ones, 6 fours. So 1 by 4 means 0.25 amps. You following? So these type of problems are very important and interesting as well, right? The potential difference across the electric lamp and conductor. So basically they are asking, let's say V1. If say this is V1, then what is V1? And across the bulb, that is V2, for example. So what is V2? Now, what is V1? The potential difference across the conductor, which has a resistance of 4 ohms. Now, V1 we need to find. I know R1. What is R1? R1 is what? 4 ohms. I know the current that is flowing through that resistor. What is that current? The current is 0.05 amps. Now, what is V? So V1 equal to I into R1. I can write that, right? So what is I? 0.25 into R is 4. So 0.25 into 4 is 1 volts. So V1 is 1 volt. Now, what is V2, right? So what is V2? V2, I don't know. Let's find it. Then what is R2? R2 is the resistance across the bulb, that is 20 ohms. And what is I? I is the same across the bulb as well, that is 0.25 amps. Then what is V2? V2 is I into R2. So what is I? 0.25 into what is R? 20. So 0.25 into 20, that is 5 amps. So V2. So as per Ohm's law, V equal to V1 plus V2. Right? In a series circuit, this V, the potential difference at the source should be the sum of all the potential difference across the circuit in series. So what is V1 is 1 plus V2 is 5, that is 6 volts. Sorry guys, this is volts. I don't know why I wrote amps, right? We are finding the potential difference. So this is 6 volt. So we can verify it like that also. So if you have two resistors, if you find the potential difference across those resistors, if you add, that should match with the source potential difference, which is 6 volts here. Okay, hope you guys understood, right? So these type of problems you can get in using a series connection. So in series connection, what you need to do, you just need to sum all the resistors to get the equivalent resistance. Okay, let's see this one, another one. A battery of 9 volt is connected in series with resistors of zero point 0.2 amps, zero point 0.3, zero point 0.4, zero point 0.5, and 12 amps respectively. How much current would flow through the 12 ohm resistor? So how many resistors are there here? 1, 2, 3, 4, 5 resistors. So basically this is 1, 2, 3, 4. So these 5 resistors are there. This is connected to a battery, right, of 9 volts. This is a switch, and then there is an ammeter to read the current. And as they are connected in series, right? So I should be same across everywhere. Same amount of current will flow. That's why I everywhere. And this is R1, R2, R3, R4, and R5. First, I need to find what is that current that is flowing. So V equal to I into R equivalent, right? Then I'll get the current in the circuit. What is R equivalent here? Our R equivalent equal to R1 plus R2 plus R3 plus, there are 5 resistances, 5 resistors, right? So all the resistances you need to add. So that is 0.2 plus 0.3 ohms plus 0.4 plus 0.5 plus 12. So how much this is? 0.5, 1, 1.4, so 13.4. So this is 13.4 ohms. That is R equivalent. Then what is the current? So V equal to IR. That means I equal to V by R equivalent. Is this correct, guys? So 0.2, 0.3 is 0.5, 0.9 plus 0.5 is 1.4 plus 12. Is that 12 or 1.2? Yeah, it's given as 12. That's fine. So 1.4 plus 12 is 13.4. Okay. All right. So what is the voltage? 9 volts by 13.4. Yeah, I don't know if we can simplify this. 3 threes, 3. Yeah, I don't know. So I can leave this as 90 by 134. I can write this, right? I multiplied and divided with 10. So this many amps. Now, how much current would flow through the 12 ohm resistors? So now how much current will flow from the 12 ohm resistor? This is the same current, right? So I is same across all the resistors, across all the resistors when connected in series. So this is just a tricky question, whether you will remember that concept or not, when connected in series. So in series, you will have same current. So that is 90 by 134 amps. I have not simplified. So the same current will flow through R1, R2, R3, R4, R5. Okay. This is just to test your knowledge. Okay. All right. So that is about series. So the equivalent resistance in series is you need to just add those resistances. Now, what happens if we connect in parallel? Let's understand what is parallel connection means. So let's say I have three resistors. This is R1, this is R2, this is R3. So I have three resistances, R1, R2, R3, connected like this to a battery source, which is V. And here you have a switch, and then I have a meter to measure the current. So this is the circuit. Now here you have a voltmeter, sorry, you have a voltmeter which is connected at the terminals of this junction and this junction. Okay, so here I amount of current will flow. Here also I, but here when you see here at the branches, the current has to split. The same amount of current cannot be flown. So then this divides into I1, I2, and I3 across each resistor. And here also I1 current, I2 current, and here I3 current. Here I1 plus I2 plus I3, that means here again it is I, the total current. So it divides and then at the end it joins. So what is happening across the resistors, different amount of current is going here. You understood? So here, what is constant in a parallel connection? The potential difference is constant. So in series, sorry, in parallel, potential difference is same or constant. So here potential difference is same, but in series connection, the current is the same. Understood? So then here in this circuit, this I is basically I1 plus I2 plus I3, right? So the total amount of current in the circuit is divided into three parts here. I1 plus I2 plus I3. Then what is I? V equal to I into R equivalent, right? Then what is I? I can write as R equivalent by, no guys, V by R equivalent, right? Then what is I1? I1, the potential difference is the same, but the resistance is R1. Similarly, what is I2? I2 I can write as V by R2. Then what is I3? V by R3. Then in this formula, I equal to I1 plus I2 plus I3. What is I? V by R equivalent. I am trying to find what is the equivalent resistance when the three resistors are connected in parallel. Then V by R1, I1 is, right? I2 is V by R2 plus I3 is V by R3. So V by R equivalent equal to, if I take V common from this, then it is 1 by R1 plus 1 by R2 plus 1 by R3. So V I can cut. Therefore, I can write 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula for equivalent resistance for the resistors when they connected in parallel. So 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. For example, I have two resistors. R1 is R and R2 is R. Then the equivalent resistance I can find is 1 by R equivalent equal to, there are only two, so I can just add 1 by R plus 1 by R. This becomes 2 by R. Then R equivalent becomes R by 2. So basically what happens in a parallel connection is, if you add same resistance, then if two resistance, then the effective resistance or the equivalent resistance in the circuit becomes half of it. If you add three equal resistance, then it becomes R by 3, 1/3 of the resistance. So resistance will decrease in parallel connection. So the household connections are in our homes, right? We have the connections from the current meter, right? That connections are all household connections are always in parallel. Okay, because our electric appliances need same potential difference across, like a fan needs the same potential difference, TV needs the same potential difference. So to supply same potential difference across all the appliances in a home, we connect that in parallel. That's one reason. And the other reason is, when we connect the appliances in parallel, the resistance will drastically reduce. So if I have 10 appliances of the same resistance, then effective resistance is R by 10, 1 by 10th of the resistance. If I connect in series, the resistance will be 10R, right? Where is 10R? Where is R by 10? So if we have less resistance, the current flow will be higher. So we prefer household connections in parallel because the equivalent resistance will reduce, effective resistance will reduce. That will allow more current to flow through the appliances. Okay. All right. So this is about parallel. So in parallel connection, what is the equivalent resistance? The equivalent resistance formula is 1 by R equivalent equal to, if you have three resistance, then 1 by R1 plus 1 by R2 plus 1 by R3. If you have four, you will add just plus 1 by R4. If you have only two, then 1 by R1 plus 1 by R2. Okay. So that's how we can find the equivalent resistance when they are in parallel. So let's do a couple of problems. Resistors in parallel. So in this circuit here, right? Yeah, ignore this. In this circuit here, R1 is 10 ohms. So this is 10 ohms. Okay. Then R2 is 40 ohms. Okay. Then R3. So if you see these two are connected in parallel, because if I amount of current is coming here, that I amount of current has to divide into I1 and I2. So the same amount of current is not flowing. That's why these two resistors are in parallel. And again, here I1, I2 combines and same I amount of current will flow through the ammeter. And then it comes here, and here again, I current has to split into. So I have used I1, I2 there, right? So I'll use I3, I4, and I5. It has to split into three parts here. And then again it joins with I. That means these three resistors are in parallel, and these two resistors are also in parallel in this circuit. Okay, so now it is connected to a source of 12 volts. So V is given. Sorry guys, V is given, that is 12 volts, and R1, R2 we know. R3 is how much? 30 ohms. So this is 30 ohms, and R4 is 20 ohms, and then R5 is 60 ohms. Okay, guys. So this is what the data given. Now what we need to do, calculate the total resistance in the circuit. So how to calculate total resistance? First, I will target this area, the upper circuit area. So here R1 by R equivalent equal to 1 by R1 plus 1 by R2 for this, the upper circuit, right? First, let's find that. So that equal to 1 by 10 plus 1 by 40. So what is the LCM? LCM is 40. Then 4 plus 1. So 5 by 40. So 5 ones, 5 eights. That is 1 by 8. That means 1 by R equivalent equal to 1 by 8. So R equivalent equal to 8 ohms. So this effective resistance is 8 ohms. Now, let's say R equivalent 1. Okay, the upper part. This is R equivalent 1. Now I'll find the R equivalent to 2. So there are 3 resistors. So R equivalent to 2 equal to 1 by R3 plus 1 by R4 plus 1 by R5. Hope you guys are following, right? So this is 1 by 30 plus 1 by 20 plus 1 by 60. And what is the LCM? LCM is 60. Then 32s, 23s, 61s. Hope you guys know how to do LCM, right? So this is 6 by 60. That means 6 ones, 6 tens. So this is 1 by 10. What is this 1 by R equivalent to 2? Then R equivalent to I can write as 10 ohms. So I got the effective resistance and the upper part of the circuit and the bottom part of the circuit. Now I can simply transform this circuit into a simpler circuit as I have already found the battery. Also, I'm just denoting with one symbol. Can I transform to this? Because here this is R equivalent 1 and this is R equivalent 2. Here I amount of current is going. Here also I. Here is also I. Here is also I. That means R equivalent 1 and R equivalent 2 are in series here. Okay. Therefore, R equivalent equal to they are in series. You understood, right? Once I simplified this diagram. So what is R equivalent 1? 8 plus 10, that equal to 18 ohms. This is the effective or the total resistance in the circuit. So when it is in parallel, first simplify and find the equivalent resistance, and then simplify the circuit and see which are in series and parallel, and based on that you can find the total equivalent resistance. So I considered here the upper part and found the equivalent, and the bottom part of the circuit found the equivalent, and when I simplify I can see this is in series. So I have added R equivalent plus R equivalent to 2 to get the total resistance in the circuit. Now the total current flowing through the circuit. So total current is very simple, right? V equal to IR. V equal to I into R equivalent. So I is what? V by R equivalent. So what is V? V we know, right? 12 volts in the at the source. By what is R equivalent? 18. So 6 2s, 6 3s. So 2 by 3 volts or 0.67 volts. Sorry, amps. That's all for today's session. I hope you all understood the topic, and I'll see you next time. If you have any queries on this, you can reach me on my Urban Pro profile. Thank you, guys.